It started as an experiment, not in space, but in code. A quantum AI was tasked with something no human researcher had ever fully accomplished: to sift through over 1,000 verified UFO videos, pilot encounters, and Pentagon-confirmed military sightings, and find what connects them all. What it discovered stunned the scientists who built it. Across 47 separate incidents, spanning decades and continents, the AI detected the same propulsion signature, a pattern of movement that defies every known law of physics. Abrupt accelerations, hovering without visible thrust, instantaneous direction shifts, and unexplained energy spikes caught on radar and infrared sensors, all repeating, identically, across events that were supposed to be random. For the first time, a machine learning system found order in what humanity thought was chaos. So what exactly did this AI uncover? And more importantly, what does it mean for the mysteries still hidden in our skies? Let's dive in. It all began at a joint research initiative between NASA's Quill Lab and IBM's Quantum Systems Group. The goal? To test whether quantum computers could detect hidden patterns in massive, unstructured datasets, the kind of chaotic, messy information that traditional supercomputers struggle with. The data of choice: unidentified aerial phenomena, or unidentified aerial phenomenons, what the world calls UFOs. From military radar recordings, Navy pilot footage, civilian videos, and infrared satellite data, scientists assembled the largest known multi-source unidentified aerial phenomenon dataset ever processed, over 10 petabytes of visual, infrared, and telemetry data. Normally, it would take months or years to analyze. But a quantum processor doesn't work like an ordinary computer. While a classical system tests one possible solution at a time, a quantum system can explore millions of possible explanations simultaneously, each encoded in the unique quantum state of its qubits. That's how the Google Sycamore and IBM Osprey processors performed the analysis, testing every conceivable pattern in motion, acceleration, and energy emission, all in parallel. What would take a supercomputer weeks, the quantum AI finished in less than a day. After billions of pattern comparisons, a consistent anomaly emerged. In 47 of the 1,000 cases, spanning over 40 years of recorded incidents, the AI detected a distinct motion curve, a sharp triangular acceleration profile, where velocity increased exponentially in under 0.03 seconds with no thermal signature, no visible exhaust, and no inertia lag. Infrared data from the US Navy's Gimbal and Go Fast encounters matched perfectly with older radar echoes from the 1980s Belgian wave sightings and even modern pilot videos from Japan and Chile. The same energy bloom pattern, a brief spike in localized electromagnetic activity, appeared across completely unrelated events. Traditional machine learning models can't handle uncertainty. They process data linearly, trying to find averages, not outliers. Because each qubit can exist in multiple states at once, quantum processors can evaluate billions of pattern possibilities in superposition, seeing relationships that don't appear in ordinary math. This makes it uniquely suited to identify nonlinear movement, multisensor correlations, and energy patterns that would normally vanish in the noise. NASA's Quill Lab demonstrated this capability using the Quantum Pattern Recognition Engine, which compared radar and optical feeds frame by frame. The AI not only synchronized timestamps between military sensors and civilian recordings, but also predicted likely movement paths, sometimes before they appeared on video. It was as if the machine could anticipate the craft's motion by identifying hidden symmetries and acceleration data that no human analyst could detect. The leading theory points to non-Newtonian energy transfer, possibly involving electromagnetic field compression, a concept similar to the proposed Alcubierre warp metric or electrogravitic drives. The AI's pattern clustering even revealed that during these acceleration events, the objects momentarily phase out of visible light, matching infrared spikes as if energy is being converted into another form of radiation. One military analyst described it as, imagine something bending the fabric of reality to move, not flying, but falling forward through space. If that sounds like science fiction, remember even the Pentagon has confirmed that multiple unidentified aerial phenomenon videos are unexplained aerial phenomena, not known aircraft or natural weather events. And now, quantum AI has given that claim a measurable foundation. Before the AI could even begin, the dataset itself had to be cleaned and synchronized. Civilian footage required manual calibration using star maps and horizon data. But the AI's results didn't stop at movement signatures. It also uncovered electromagnetic echoes, recurring frequencies between 2.8 and 3.2 GHz during several radar-tracked events. These frequencies coincide with natural atmospheric resonances, but in these cases, they appeared artificially amplified. That discovery led some scientists to theorize that these objects might be generating localized plasma fields, essentially ionizing the air around them to reduce drag and radar visibility. NASA and the Department of Defense haven't released all of the AI's findings yet. But insiders say a second phase of the project is already underway, this time feeding in real-time satellite feeds and atmospheric radar data to see if the same pattern reappears. Patterns we couldn't see are there, hidden beneath decades of confusion, skepticism, and denial. So what is 3i/Atlas to astronomy, is what quantum AI might be to human understanding, a new lens revealing the invisible. We're only beginning to decode what's really out there. But one thing is certain, the sky above us holds secrets, and for the first time, a machine might be ready to tell us the truth. If you love exploring the edge between science and the unexplained, subscribe, like, and turn on notifications, because what comes next could change how we see the universe forever. Thank you for watching my channel.